Hi everyone, this is Teacher Justina and welcome back to my YouTube channel. For those who are not yet done subscribing, please do subscribe. Our video for today is all about the laws of logarithm. So let us try this example. So the first law of logarithm is said to be the logarithm of a product. So the logarithm of a product is being denoted by this log of mn. The mn there are the two factors to the base a is equal to log of m to the base a plus log of n to the base a. And this means that the logarithm of the product, so the product of m and n of two numbers, so the two numbers are m and n, is the sum. So this one is the sum of the logarithm of the two factors. So the two factors are m and n. So we will be adding the logarithm of the factors. Let us have this number 1. So the log of 20, how do we use the logarithm of the product? So we will be factoring out the 20. So 20 can be factored out by log of 4 times 5. So since we'll be applying the logarithm of a product, we will be getting the sum of the logarithm of the two factors. So we will be having this next step, the log of 4, this one, the log of 4 times 5 in there, but in the notation, it will be adding. So log of 4 plus the log of 5. And so far, if you want to check if it is really correct, so for the log of 4, if you will be using your calculator, that will be 0.602, the value of log of 4, plus the log of 5, which is 0.699, will gives us 1.301. So in other words, the log of 20 is equivalent to 1.301 applying the law. But it is wrong if you will say the log of 20 will be log of 4 times log of 5, and uh, that will be a wrong concept. So let us try number 2. Number 2 is log of 3xy to the base c. So applying the logarithm of a product, so far there are three factors, the 3, the x, and the y. And so far, applying the first law of logarithm, we will be adding their factors. So we have the log of 3 to the base c plus the log of x, this one, to the base c, then the log of y to the base c. Okay, so we were able to expand the log of 3xy to the base c into this one, applying the logarithm of the product law. Let's proceed to example number 3. Log of 2 over 7h cubed to the base of 5. So still, we will be applying only the first law, that we will be adding the sum of their logarithm. So remember, we have two factors, the 2 over 7 and the h cubed. So therefore, the log of 2 over 7 to the base 5 plus the log of h cubed to the base 5. Okay, so the last example for the law, we have log of square root of 5 or h to the base m. Again, we have three factors. Square root of 5 is one factor, r one factor, well, h is another factor. So there are three factors all in all. In other words, we will be adding the logarithm of these three factors. So therefore, this will be log of square root of 5 to the base m plus the log of r to the base m plus the log of h to the base m. Okay, so let's proceed to the next law. Okay, and the next law of logarithm is said to be the logarithm of a quotient. So when we talk about quotient, we will be talking about dividend and the divisor. So it is being denoted by log of m over n to the base a is equal to the log of m to the base a minus the log of n to the base a. So in other words, the logarithm of the quotient of two numbers, the m and n, is the difference. So therefore, it's no longer sum, but it's difference of the logarithm of the dividend and the divisor, meaning we will be subtracting the logarithm of the numerator minus the logarithm of the denominator. So let us try this example number 1. Log of 35 over 7. Applying the law, we will be having the log of 35 minus log of 7. How do we know if we are checked, if really we will be subtracting the logarithm of 35 minus the log of 7? So remember that the log of 35, if you'll be using your scientific calculator, that will be 1.544, and uh, the log of 7 will be 0.845. When subtracting, the result will be 0.699. So the log of 35 over 7 will be 0.699. Let's proceed example number 2. This number 2, we have log of d over 2x to the base 3. So as we are to recall the first law, we are talking about the logarithm of a product. So we are going to familiarize the dividend and the divisor. So the dividend is single factor, while the divisor is 2x, meaning we have two factors, and then we will be applying the law, the logarithm of a product. So applying first, the logarithm of a quotient will be the logarithm of d, the d is our dividend, to the base 3 minus the logarithm of 2x to the base 3 is our dividend. But we are not yet done because I am done introducing the logarithm of a product. So we will still uh, apply the logarithm of a product in this log of 2x to the base 3. So the final step will be log of d to the base 3 minus the 2x is two factors. Thus, we will be adding the logarithm of their factors. So log of 2x to the base 3 will be log of 2 to the base 3 plus log of x to the base 3. Next, number 3. This is log of m and k over a to the base t. As you have seen, our numerator is made up of three factors while our denominator is composed of one factor only. So first, we are going to apply first the logarithm of a quotient by subtracting their logarithm. We have the log of m in k to the base t minus the log of a to the base t. But remember that this one is to be expressed into logarithm of a product. So therefore, the final answer will be log of m to the base t plus log of n to the base t plus log of k to the base t minus log of a to the base t. So that's the final answer in number 3. Okay, let's proceed to the next, number 4. Log of v cubed over square root of d to the base 6. First thing is we are going to apply the logarithm of a quotient by subtracting the dividend minus the logarithm of the divisor. So we have log of v cubed to the base 6 minus log of square root of d to the base 6. But remember that that is already final, because we are only applying the logarithm of a quotient by subtracting their logarithms. So let us proceed now to the next. Okay, so let us have the third law of logarithm, the logarithm of a power. The logarithm of a power is being denoted by log of m to the exponent of k to the base a is equal to k times the logarithm of m to the base a. In other words, the logarithm of the kth power. So in other words, the logarithm of kth power of a number. So that number is being raised to an exponent of k is equal to the logarithm is equal to k, that's one, k times the logarithm of the number m. So let us have this example number 1. Log of 9 squared to the base x. So applying the logarithm of the power, this will become the 2 as an exponent will be placed in that will be placed before the logarithm of that number. So the logarithm of 9, still we copy the base x. So this is already the final answer in number 1. Next, number 2. Log of d cubed is b cubed to the base w. Okay, so we are going to have this this process or this step, or this is considered already final. Okay, so the 3 there is the power of d, so we will be placing it before the log of d to the base w. And since the s has no power, although it's imaginary one, but we still have to write it, but there's no number before that log of that s. And then since the b has a power of 3, that is why the 3 is being written before the log of b to the base w. In other words, you try check, there's no cube after the d because it is written already there, and there's no cube anymore in this b because it is already written before the log. Okay, so in other words, this is already the final in number 2. Okay, let's proceed number 3. Okay, by the way, talking about number 2, why we're able to express it in here as we are applying the logarithm of a product, because we have 1, 2, there are 3 factors already, so we are going to add their logarithm of the factors, and at the same time applying the logarithm of a power. Number 3, the log of 3g squared n over square root of z to the base 3. First is we are going to consider that this is already a logarithm of a quotient. So if it is logarithm of a quotient, we are going to subtract their logarithm. So rewritten we have rewritten the second, this is the dividend, and this is the divisor. So since it is expressed as a quotient, so meaning we are going to express it as the difference of their logarithm. And next, why this is z to the power of 1/2 from the square root of z. Remember that the square root is being represented by a fractional exponent of 1/2. So there's no radical sign anymore, but instead we have the exponent, which is a fractional form. We are not yet done because we are going to apply the different laws, the logarithm of a product and the logarithm of a power. So therefore, what is the next step? The next step will be, remember that we have 3 factors in here, the 3, the g squared, and the n. In other words, we will be adding their factors. So log of this one, log of 3 to the base 3 plus log of g squared to the base 3 plus log of n to the base 3 minus log of z to the power of 1/2. So the next step is, remember that the g has a power of 2 and then the z has a power of 1/2. So what shall we do with them? We will be applying the logarithm of a power. So since this one, the 3 there has no power, this one, the 3 has no power, we will be rewriting it. So we were able to rewrite the first term in here. And since the g has a power of 2, thus we will be isolating the 2 there and written before the logarithm of that g to the base 3. And then rewriting this, because the n has no power at all except that imaginary one, so we just simply rewrite it. And since the log of z to the 1/2 is a power, thus we will be rewriting it before the logarithm of z. So 1 minus 1/2 log of z to the base 3. Okay, so guys, I hope you have learned something from my videos, the logarithm, the laws of logarithm, from the logarithm of a product down to the logarithm of a power. This has been Teacher Justina, and thank you for watching. That in all things, God may be glorified.